Okay, here's yet another example for completeness that would have been in class 15. This is the inverted slider crank example. I'm taking this problem, Norton's problem 6.8a. So they have a bunch of other different ones. So this would be the first one in there. They don't have an example in the book for this. So we have A, this distance right here is going to be 2 inches. C right here, so that's going to be link 4 actually, is going to be 4 inches. Gamma is 90 degrees. So often they draw this like it's 90 degrees, but it doesn't have to be. I kind of prefer to leave them as 90 degrees, but it could be a bunch of different other things. And then D is link 1, so it's this distance right here is going to be 6 inches on this. The length of 3 right here, that actually varies, so that's why we don't have a B listed in here. And we want to find, and so this is incorrect here, because we're given that omega 2 is this, so we don't want to find omega 2 because it's given. Omega 3 isn't really all that important to us. It's really omega 4 that we want to find. And we want to find the velocity of A and the velocity of B. And let's just find it in the open position here. All right, so in the open position, all right, because I don't want to go through the whole thing. So in the open position, we're able to calculate from a position analysis that these things are true. It'd be good to see what this thing looks like, because this is the generic version right here. So let me see, I'll keep that, and I'll come up and go into here, and let's see, boom, boom. I think these are all the wrong ones. No, well, here you go. This is the inverted, this is the configuration that it looks like right here. So at this instant, I'll write on this and hopefully I can get rid of it. Which way is it saying? It says it's going to go 10 radians per second. So this is actually coming that way right here, so that you can get a sense of what this is going to happen. And remember that this guy extends through, and that this length right here, it can, it's got a little thing right here, so this can slide back and forth through there. So going back and into the calculations, and we'll do an Excel version of this, once again, just for completeness. We might use it some other year. So omega 4, these are the equations that are applicable here out of the textbook. We go A times omega 2 times cosine of theta 2 minus theta 3 divided by B plus C times the cosine of theta 4 minus theta 3. And that's going to be equal to 2 times 10, that was the input, times the cosine of 30 minus 232.7 divided by 1.793 plus 4 times the cosine of 142.7 minus 232.7. By the way, this guy right here is often gamma, just so you know. Well, let me erase that. It's interesting. Oh, I guess because I kept it. Yeah, that's why. Okay. This is also gamma, which is equal to 90 degrees in this. Or it might be negative. Yeah, it's negative 90 degrees. Yeah, you got to be careful there of what I said. And then this comes out to a negative 10.29 radians per second right here. And so that's equal to, and by the way, that's also equal to omega 3, by the way. So, and they're saying it's, since it's negative, that means that it's going clockwise right here. So this is omega 4. And remember that these things are tied to each other by this gamma. So they're actually kind of going to both rotate at the same angular velocity. They're tied to each other. They can't move, right? Because that's a hard and fixed angle right in there. So other things that we're going to find here, we also want to get the b dot. So it's going to be a negative a times omega 2 times the sine of theta 2 plus omega 4 times b sine of theta 3 plus c sine of theta 4, boom, boom, and divided by our cosine of theta 3. Theta 3, baby. Come on back to top. All right. And so we go negative 2, 10 sine of 30 plus negative 10.29. Damn thing. Hate that thing. And then go 1.793 times the sine of 232.7 plus 4 times the sine of 142.7. Close that parentheses. Cosine of 232.7, and it ends up getting us a b dot of 33.44 inches per second. Now, if I want to find the velocity of A, if we look back at this guy right here, we will see, well, I didn't write out the vector loop, so I'll write it down here. That the vector loop, once again, was going to be A omega 2 J E J theta 2, or 2 times 10 times negative sine of 30 degrees plus J times the cosine of 30 degrees. And that's going to end up being equal to a negative 10, plus J times 17.32 as inches per second, which is, we would end up finding it's going to be 20 inches per second, which is stupid because it's 2 times 10 radians per second, so duh. And then right here, I think I didn't even write down the angles, and I should have, right? So the angle we were told of that and the input was going to be 30, so this is probably going to be 60 degrees right here. And then the VB right here. Okay, so VB, okay, yeah, that's going to be equal to C omega 4 J E J theta 4, so it's going to be 4 times, and that we got that 10.29, and then it's the negative sine of our 142.7. We might want to double look at that again just to see what that looks like, and the cosine of 142.7, and we end up with a 24.94 plus J is going to be 32.74 inches per second, which ends up being 41.16. I wrote meters and I wrote inches per second. And if we take the inverse tangent of the 32.74 divided by the 24.94, we get 52.7 degrees. And if we wanted VA with respect to B, we would just take A and subtract out B. And that's going to be, I mean, it's not really all that important to us. It's hard to actually picture this one. Negative 34.94 minus J, 15.42 inches per second, or 38.19 inches per second, and that comes down this way. We find that's at 23.81 below the horizontal to the left. And note, though, that the length 3 is not a rigid body right here, all right? So it is actually shrinking right here, but if we wanted to find how A and B are related to each other, we would use this velocity of A with respect to B. We have to be careful here that we, when we have the vector loop of this right here, that it has 4 parts to it instead of the standard, what we've been seeing with the other problems, that they have 3 parts, right? So that you're going to have A omega 2 j e to the j theta 2, and I think in this, yeah, you will have it because it's going to be negative right there. Oh, no, we got to be careful there. I got to be careful how I say that. Let me double check on something. Whoop, come back to it. We have the B dot of 33.4. Yeah. So yeah, we got to be careful. I got to be careful how I say that in this thing. Double checking. Where'd you go? You're right in here. We take a look, and yeah, we gotta, so we got 2 parts to it, yeah, so it goes minus B omega 3 J cosine, so that should have been J, cosine of theta 3 minus B dot cosine of theta 3 minus, excuse me, let me take care of all this. Maybe I should just edit this out. Maybe. I don't know if I know how to. I do, but it's a pain in the ass. I want to write, this is the generic one. I started to write it for the x direction, or the real direction. So B omega 3 j e to the j theta 3 minus B dot, B dot j e to the j theta 3, and then minus C omega 4 j to the e j theta 4 equal to 0. And what I want to emphasize here is this is velocity of A. This was the velocity of B. And this whole thing right here is the velocity of A with respect to B. All right, so that was my point, actually, that we don't want to just jump in. We had been used to saying that this right here was the velocity of A with respect to B, but it's going to be both parts of this. So it's easier to just calculate it by subtracting these 2 right here, but in terms of it being built in. So I'm going to end this, and we're going to take a look at, see what these results will show us in... So let's see, I'll discard. Yeah, sure. We'll see what these results show us when we go to, I probably should have kept it. Anyway, when we go to Excel. So I'm done.